So part A of problem 22 says pick any three numbers in a row. I'll pick these three first of all. Take the middle one and square it, and then subtract off the product of the one before and after. So we're subtracting off 3 times 8. So we get 25, take away 24, and that's 1. So I did part A. Part B says do it some more times. So I'm going to do that. I'm going to get 8 squared, the middle number, minus 5 times 13. That's negative 1. I'm going to pick these three numbers, and I'm going to do the middle number, 2 squared, minus 1 times 3. And so I'm getting 1. So my guess, part C wants a guess. My guess is you're getting either 1 or negative 1. Always. I haven't proved it, but it doesn't ask for a proof, it asks for a guess, and that's my guess. So how can we find the Fibonacci sequence in Pascal's triangle? And it gives us a hint. It says use these, and when I add along this diagonal I get 1 plus 3 plus 1, and that equals 5. And if I add these along this same parallel diagonal, I get equals 3. And if I add these along this parallel diagonal, I get 2. There's only one of them here, and that gives me 1, and there's only one of them here, and that gives me 1. So let's go down here and see what happens. If I add these, I get 8. And if I add these, I have to remember to add this one though. And I have 6, and 6 is 12, and 1 is 13. And so it looks like if I add along these diagonals, carefully selected diagonals, I get 1, 1, 2, 3, 5, 8, 13. And those are the Fibonacci numbers. So 24a, we're supposed to write the first 8 terms of the Lucas sequence. It starts off 1, 3, and it works like the Fibonacci numbers. So we have 1 plus 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11, 7 plus 11 is 18, 11 plus 18 is 29, and 18 plus 29 is 47. So that should be the first 8 of them. And we're done with part A. Part B. Part B, it wants the next 2 rows of this chart. It looks like these numbers over here are the Lucas numbers, and it looks like these are the Fibonacci numbers, and these are the Fibonacci numbers where the first 2 aren't there. So, you know, this has a 2, this has a 2, this has a 3, this has a 3. They're kind of offset by 2. So this is going to be 1, 1, 2, 3. 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34. 8 plus 21 is 29, which matches that Lucas number. 13 plus 34 is 47, which matches that Lucas number. This would go on a long time, but we're asked just for the next 2 rows. B is kind of insulting. What do you observe about the first column? Well, they're the Fibonacci numbers. So on problem 25a, I keyed this into my calculator and got approximately this. There was a bunch more digits of approximation, and then I keyed in this and got approximately this, and it says how far apart are they, what the difference is. If you subtract these 2, you get about 1. So the question is it exactly 1? And the problem doesn't ask us for this, but I'm going to go ahead and do it anyway. I want to know if this is exactly 1, so I'm going to subtract these 2. We supposedly have the skills to do this. We have a common denominator of 2. We can use it. And in the numerator, we have the square root of 5 plus 1 minus the square root of 5 minus 1. And notice, that's a little bit tricky. I think I need a new pen. My Microsoft pen is not performing well. So we're going to distribute this minus sign through. And the square root of 5 minus the square root of 5 cancels, and we get 2 over 2, which is exactly 1. So this should be exactly 1.